Hey guys, what we're going to talk about is symmetry, and we're going to talk about even and odd functions also. So the first thing is we can look graphically at something, and so let's start with this first one here. Let's go like this. And hopefully you recognize it's not a function because it doesn't pass the vertical line test, but we can tell it's symmetric to the x-axis. And you learned this years ago in like the younger grades. And we did a y-axis, right? So we can do one going this way. Right, and just try to make it as nice as possible. So this is for the y-axis. And we can go through, so we got one more, right? So we can go through the origin. So that would be the origin through 0, 0. And that would be kind of like a cubic looking thing that we've been doing in class, or maybe a little tangenty. And that's through the origin. And so now we have some new words that we started here. It's called even and odd functions. Well, if it's symmetric with the y-axis, it's called an even function. And if it goes through the origin, symmetric with the origin, that's our odd function. Well, we can also look at these algebraically instead of graphically. And so what we're going to see is for even functions, if we substitute negative x in for f of x, then what we get is f of x. And so what this is really saying is we get back the original function. We get back original function. And you can see this on the graph. When you plug in a negative value of x, it gives you the same as if you plugged in the positive value of x. You get that parabola looking thing. So for the odd functions though, if you plug in negative x, well, you don't get back the original because then you'd be called an even function. But what happens for our odd function, you get back the opposite. So this is when you get back the negative of the original function. And for all of this, this is for both of these, for all x values in the domain. All right, you can't use things that are going to make the functions undefined, or they don't exist. So let's take a good look at a couple of examples here. And it says algebraically, meaning we're not going to graph these, but we will graph them just to get an idea of what they look like. Tell if the functions are odd, even, or neither. So if you're not odd, if you're not even, then you're neither. You're just a happy function. It doesn't matter. Well, we're going to do this algebraically, like they said. Well, let's go. Now, what I'm supposed to do is plug in. So what I want to do is I want to plug in negative x into the function. Now, what you do is pretty much wherever there's an x, put parentheses and substitute negative x into it. And that's going to help us when we do this, right? So now, when I squared negative x is positive x squared. So I get back x squared. So minus 3. And what we notice is that this and this are exactly the same. So what we're saying here is negative x, f of negative x equals f of x. Therefore, you are an even function. Now, even though they said do it algebraically, we can look at the picture just to confirm, as long as we're allowed to use our calculator for this part. All right, so I'm going to enter the graph, and I'm going to hit graph, and as you can see, it is symmetric with the y-axis. Therefore, it's an even function. Well, let's take a look at another one. Number 2, f of x equals x squared minus 2x minus 2. All right, you should recognize the quadratic, so it's some type of parabola. And what I'm going to do is I'm going to plug in negative x once again. And I'm going to put parentheses. Oops. All right, why don't you clean up this line here and see what you get. So hopefully you have negative x squared is positive x squared. Negative 2 times negative x is positive 2x. and I bring down this -2. Now, take a look at the original function. X squared, good. -2 in the back, -2 in the back, good. But this switched in the middle. Now, all of it didn't switch, only one part. So this is not good. So therefore, it is neither. And when I say it's not good, it doesn't really matter. It's still a good function. It's a parabola. And it's just that you can't, it's not odd, it's not even. So I can put this graph in, and we can see that it is not symmetric with the y-axis. It doesn't go through the origin. So it's just neither. Let's take a look at another one. Number 3. So once again, we're going to algebraically, right? So I'm going to plug in -x. All right, why don't you clean this up and see what you get. Well, -x, -x, -x is -x cubed over. This becomes +x squared. So downstairs I get 4 minus x squared. And now, when we're looking at this, now what you got to remember is when you're doing a fraction, you're allowed to have the negative, right? If you have a fraction, the negative could be upstairs, the negative could be out front, the negative could be downstairs. But there's only one negative, right? If you do it that way. So this one is, you can kind of think of this as like this whole thing, right? Doesn't matter, I can put the negative this. And if you look, there's a negative outside the original, right? So this is f of -x equals the negative of the original, the negative of f of x. So that makes it odd. Now this last question is for the honors, and if you're in the regular class, feel free to try it because it's still good to know. But let's take a look. So now we got 2 parts to worry about, and this is just a beginning question, so they're kind of easy. As we continue for the honors class, they will get harder. This question number 3 is pretty much, it's that's a normal question. So to make it harder, we put 2 functions together. So let's take a look at it. Why don't you plug in -x and see what you get. Well, before I do 4, I forgot to tell you about so I apologize, we didn't hit that last graph up. So just take a look, I typed it in real quick, and that's what you get. And next week we're going to be doing this by hand, how to graph this crazy thing without a calculator. And this has a whole bunch of things going on. It has asymptotes, has vertical asymptotes, slant asymptotes. It has roots, and it has no holes or anything. But we'll get there. So let's take a look at this one down here. So hopefully you plugged in -x. So, and wherever I put an x, I'm going to put parentheses around it, and that'll help me. So this gives me -x, and this is going to give me 4 minus x squared. And when you're looking at this, well, is this, what's special about this? Well, I could take the negative out front and go like this. And what we can say is this is the opposite of the original graph. And I'm going to type this in. And we hit graph. And this is very similar to things we've been doing in class with the polynomials. And so you can see it's symmetric through the origin. So this is actually an odd function. All right, well, that was it, and see you in class. Bye.